guys, welcome back to my YouTube channel. So today we are going to solve day 11 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2601, Prime Subtraction Operation. Okay, so let's read the problem statement first. So you are given a 0 indexed integer array nums of length n. You can perform the following operation as many times as you want. Pick an index I that you haven't picked before and pick a prime p strictly less than the nums of I. Then subtract this prime p from nums of I. Okay, we have to return true if you can make nums a strictly increasing array. Okay, strictly increasing array we need to make using the above operation, and false otherwise. Okay, if it is not possible. A strictly increasing array is an array whose each element is strictly greater than its preceding element. Alright. Okay. So here see this example number 1. So 4. Okay. So here one thing is clear that I need strictly increasing. Okay. Every time all the elements should be in increasing order. So for this 4, what is the largest prime number which is strictly less than this 4? Okay, so here see here we have to pick a prime p strictly less than that particular number. Okay, so this number is 4, so strictly less than 4, the prime number is nothing but 3, right? 3 is a prime number. Okay, so what are the prime numbers? Prime numbers are like this: 2, 3, 5, 7, then 11, 13, 17, 19, and so on. Okay, these are the prime numbers, right? Okay, starting from 2. All right, so here from 4, this 3 is the strictly less than this 4. Okay, so I am starting like this. Okay, from bottom I need to start and I need to continuously increase. Okay, so here if I just subtract this number 4 with 3, I will get the smallest number as possible, right? So this is the smallest number that I can get if I subtract this number 4 with 3. Okay, 1. So here instead of 4 I am going to write 1. Okay, I'm going to start from bottom only, right? I don't want a greater number here in the starting itself. In the starting I want the smallest number, as smallest as possible. Okay, so that is why from the strictly increasing prime factor, okay, strictly increasing strictly decreasing prime number, from this 4, this is the 3. So if I subtract this number with this 3, I will get the smallest number possible, right? So here I'm writing 1. Okay, now here 9. Okay, so from 9, so what is the strictly decreasing number from this 9? Okay, so here 9. So 9, before 9 I can subtract 7 from this 9. If I subtract 7 from uh, if I subtract this 9 from 7, I will get output as 2. I can use this 2 here, right? After 1 I can use 2. Okay, 1 and 2 is increasing, strictly increasing from 2, so I can use this 2 here. Okay, so this is good. Now next number is 6. Okay, so for 6 nearest prime number, you see here 5 I can use. Okay, so if I do 6 minus 5, I will get output as 1. But this is not the best case, right? I can't use 1 here because it is decreasing now. Okay, I can't use 1. Okay, so here can I use any other number? Instead of 5, can I use 3? So 6 minus 3, if I do, I get the output as 3. So yes, this number I can use, right? So here let's use this 3. Okay, I can use this 3. Okay, all right, now this is done. Okay, now after that here the next number is 10. Okay, so here for 10 I can subtract this 10 from 7. So if I use that, so I will get 10 minus 7, 3. I can't use this 3. Okay, because I need strictly increasing, but these 3 and these 3 are same, right? So I can't use this 7. Okay, but here I can use this 5, right? So 10 minus 5 if I do, so I get output as 5. I can use 5. Okay, so now see here all the numbers are strictly increasing. From 1 I move to 2, from 2 I move to 3, from 3 I move to 5. Okay, so this is one possibility, right? This is the one case. So we are able to arrange all the numbers in increasing order like this. Okay, so that is why we are just going to return true in this case. Okay, So here if you want to see explanation, so here in the first operation what they are doing, so they are picking first index and p is equal to 3 and then subtract 3 from nums of 0, so our array is going to become like this. In the second operation they pick the next element and p is equal to 7, they subtract 7 from that element, then they get this 1 2 6 10. After second operation they are saying that nums is already sorted in increasing order, so the answer is true. Okay, but I have solved you like this. Okay, 1 2 3 5. So here also I am returning true and this is also true. Okay, this is also strictly increasing and this is also strictly increasing, right? Clear? Now see here 6 8 11 12. Okay, you can try the same approach here as well. So you will find that all the numbers are strictly increasing, so you are just going to return true. Okay, or you can, if you want, you can directly in this case there is direct possibility. Directly you see that all the numbers are already sorted, so in that case if you don't want to apply all this operation, but let's apply all this operation. Okay, let's apply all these operations. Okay, same thing. So here now see 5 8 and 10. Okay, so here I want this number as smallest as possible. So from this 5 what I can subtract, I can subtract 3. Okay, because I need the number which is strictly less than this 5. Okay, and I need that prime number, so 3 is smallest. Okay, so 5 minus 3 2. Okay, let's say I put 2 here. Then next number is 8. Okay, so before 8 what should I put? Before 8, okay, number is 8, so can I put 7 before that? 8 minus 7 1. No, I can't place 1 here. 8 minus 5 3. Okay, 8 minus 5 I'm getting 3. Okay, so this is the only case that I can put, right? 8 minus 5 3. So this is the good case. Okay, so 8 minus 5, let's say I place 3 here. Then next number is 3. So 3 here, for 3 I can't place any other number right here. 3 I can't place 3 minus 2 as 1. Okay, I can't place that, otherwise it is decreasing. So it can be proven that there is no way to perform operation to make num sorted in strictly increasing order. Okay, so the answer is false. Okay, so in this case there is no possibility, right? So you can try all these things. Okay, whatever I explained here, pick that number and pick the nearest prime factor which is strictly less than that particular number. Okay, that particular number, and then do the subtraction and make sure that this number and this number. Okay, so here it should be in increasing order. If it is not in increasing order, then don't use that. Okay, that's a simple thing. So if we don't find any case here like this, so here from here I'm simply going to break and going to return false. That's it. Okay, so simple story. Okay, so here if you see in this problem, constant size is very small actually, just 1000, right? So I think we can solve this problem using greedy approach. Okay, let's see. So I think it will be solved using greedy. Okay, so here first thing, how we are going to check if a number is prime or not. So for that purpose, let's write first one boolean function, let's say is prime. Okay, so private, let's give the type as boolean is prime, and here I'm just going to pass a number to check if it is a prime number or not. Okay, that's a simple meaning. So we know that if a number is less than equal to 1, then simply means we have to return false now, because 1 is not a prime number, right? Okay, so 0 and 1 are not prime numbers. All right, and if number is less than, I say if number is less than equal to 3, so here there are two possibilities, 2 and 3. Okay, if a number is 1, then definitely this case will be executed first. Okay, but here I'm writing number is less than equal to 3, that simply means 2 and 3. So we know that 2 and 3 are prime numbers, so here I'm simply going to return true. Okay, and after that all the multiples of 2 and 3 are prime numbers, right? Are not prime numbers. Okay, so here 4 is not a prime number, 6 is not a prime number, 9 is not a prime number, 8 is not a prime number, 2 4 is a multiple of 2, this is multiple of 2 and 3. Okay, and this is multiple of 2, right? And this is multiple of 3. Okay, so here I'm just saying that if a number is completely divisible by 2, okay, or if my number is completely divisible by 3, then in that case simply return false. Simple. Return false. Eliminate multiples of 2 and 3 early. Okay, so now here we have checked about numbers like 1 we have checked for 2, we have checked 3, and we already know 4. Okay, then now 5 is the case. Okay, now let's check about this 5. Okay, so we know that 1 is not a prime number, false. 2 is a prime number, true. 3 is a prime number, true. 4 is a multiple of 2, so this case will give me false. Okay, so now but about 5. So this is the next possibility, next number we have to check. See, after 5, what is the number? 6. Okay, so can I write 6 like this? K, 6k. K, if it is 1, then I will get element as 6 only. Okay, if my k is 1. Okay, so here 6, if my k is 1, then next number is going to be 6k if k is 1. Okay, I'm saying if k is 1, then next number is going to be 6 only. Here I can write like this, 6k plus 1, then this simply means this is 7. 6k plus 2, that simply means that this number is 8. 6k plus 3 simply means 9. 6k plus 4 simply means 10. 6k plus 5 simply means 11. Okay, so now here see this. Okay, this k doesn't matter. Okay, here if I divide this number with 2, it will always be divisible. Okay, 6 into k, if k is 1, then I get 6. If k is 2, I get 12. If k is 3, I get 18. So this number is always going to be divisible, right? So our 6 is not a prime number, right? False. Okay, now here see possibility. If k is 1, 6 plus 1, 7. Okay, I get 7. If k is 2, I get 13. If k is 3, I get 19. So I'm getting what? I'm getting here prime numbers, right? This 7 is a prime number, 13 is a prime number, 19 is a prime number. Okay, this case, for this case. Okay, and then 25, then 25 will come, but 25 is not a prime number. Okay, so this is the one case that we need to check here, because in this case there are going to be some numbers which are prime numbers, right? 7, 13, 19, and some numbers which are not going to be prime. Okay, so this is the one case that we need to check. We can ignore this case. Okay, so this is the one case that we need to check. And in this case, always if you divide this number with 2, always get, you are going to get a composite number only. Okay, k is 1, so 8, 8 is divisible by 2. 6, 2, 12 plus 2, 14, 14 is divisible by 2. So we don't need to check this case. We don't need to check this case because this number is always going to be divisible by 3. Okay, so just k, place any value of k, and you will see that this number is going to completely divisible by 3. 6, 3, 18, 18 plus 3, 21, 21 is completely divisible by 3. Okay, so we don't need to check this case. This is always going to be divisible by 2. We don't need to check the numbers like this, but we need to check the numbers like this, because here if my k is 1, I get 11. If my k is 2, I get 17. If my k is 3, I get 23. If my k is 4, I get 29. If my k is 5, then I get 35. Okay, this 35 is a composite number, but all other are prime number. So this is one case we need to check. Okay, so in this way we are checking. Okay, so here this, and then this 6k plus 1 and 6k plus 5. Okay, this is going to be our focus. Now here I'm just going to check for int I is equal to 5, and here I'm just going to write I into I should be less than equal to number, and here I'm just going to increment this I with 6. Okay, and here inside this I'm just going to check if number modulus with I modulus with I, if it is equal to 0, or number modulus with I plus 2 is equal to 0. Okay, so here if you see, uh, we are checking for 5 here if my I is at this position, and we are also checking for 7. Okay, we don't need to check 6, 8 and 9, I told you, right? So we are checking for 5 and 7. So that is why I'm writing here I, and here I'm writing I plus 2. Okay, now next time I have to check for this number, right? 6k plus 5. Okay, so that is the reason here, if you see, I is equal to 5. After that I was using 5 plus 6, 11. Okay, so here 11. So next time I'm going to use 11. Okay, so that is why this number we have to check now. So that is why I am adding 6 in my original I. Okay, so then next time it is going to check for 11 and 13. Okay, so that's the simple reason. All right, and here inside this, you can also write this function in a simple manner. Actually, this is just a little modification of that one. Okay, so that we get some faster result. And here we are just going to return true. Okay, this is done. So we have checked for all these cases. All right, now inside this we have to just write few things. Okay, so here int n is equal to nums dot length, and now inside this we are just going to process the first element first. Okay, so for int first prime is equal to nums of 0 minus 1. Okay, so from opposite direction I'm checking. Okay, and here my first prime should be greater than equal to 2, I'm saying, and here first prime minus minus. Okay, so we need to keep the first number as smallest as possible. Okay, this number as smallest as possible, so that's what I'm doing here. Okay, and here we are just going to check if is a prime this first prime. Okay, if it is prime, then simply update my nums na. So here I'm just going to write nums of 0 is equal to nums of 0 minus here your first prime, right? First prime, and break it. That's it. Okay, so for first element this is done. Okay, that's what we need to do here. So here this for loop ends. Now we have to process each subsequent element after that. So here I'm just going to run one loop. Int I is equal to 1 index. Now I is less than n and I plus plus, and inside this I'm just going to check. I'm going to write first boolean and found prime. Okay, if I found any prime which is validating my cases that I'm checking. Found prime, and I'm initially setting it to false. Okay, and original value, int original value is equal to nums of I, and then after that I'm just going to iterate for int prime, and reverse I have to iterate, right? So here nums of I minus 1. Okay, minus 1 from previous numbers which are strictly less than that particular number. That's a simple reason I'm going to write like this. And here my prime should be greater than equal to 2 and prime minus minus. Okay, inside this I'm just going to check if is prime this prime. Okay, if it is prime, and one more condition I have to validate here, that is nothing but if nums of I, okay, nums of I, if I subtract it from prime, okay, subtract it prime, okay, and then it should be my greater than my previous element. Okay, nums of I minus 1. Okay, that's what I need to check. Okay, here and here inside this I'm just going to update my nums of I with nums of I minus prime. Okay, so here I'm just going to write nums of I is equal to nums of I minus prime, and found prime I'm going to set it to true. Okay, found prime is I'm going to set it to true and break it early exit. Okay, we have found one number. Okay, so here once this is done, we have to check if no valid prime was found, but if leaving that particular number unchanged still maintains order. Okay, so here I'm just going to write if not found prime and nums of I, okay, it should be less than equal to, okay, if it is less than equal to my nums of I minus 1, then in that case simply return false now. Okay, that's what we need to do here, simply return false. Okay, so what we are doing, we are checking if no valid prime was found. We have to check if leaving nums of I unchanged still maintains order. Okay, and we are returning false if we can't maintain strictly increasing order, and in the end just return true. If we didn't execute our false statement anywhere, just return true. That's it. Okay, so now let's submit it. So see, our solution is accepted, right? I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.